Muy buenas tardes, bienvenidas, bienvenidos. A los 7 días del mes de noviembre en el Salón de Grados se da inicio al acto en el cual se hará entrega del título de Visitante Distinguido de esta casa al doctor Marc Ballouz. Preside este acto la vicerrectora Magíster Mariela Marquicio, el profesor emérito de la Facultad de Ciencias Exactas, Físicas y Naturales y jefe de gabinete de asesores del rectorado, ingeniero Roberto Terzariol, el decano de la Facultad de Ciencias Exactas, Físicas y Naturales, ingeniero Pablo Recabarren. Se encuentran presentes autoridades y miembros de la Universidad Nacional de Córdoba y de la Facultad de Ciencias Exactas, Físicas y Naturales, integrantes del Consejo Nacional de Investigaciones Científicas, CONICET, autoridades provinciales, representantes de la Universidad Tecnológica Nacional Regional Córdoba, profesores eméritos, investigadores, docentes, no docentes, estudiantes e invitados especiales, representantes de organismos y asociaciones vinculadas a la temática. Seguidamente, el profesor emérito ingeniero Roberto Terzariol nos presenta al homenajeado.
Le pediría que primero al señor decano si quiere decir algunas palabras. Muy breve lo mío. Vamos a tratar de hablar en las dos lenguas para todo el mundo. Good afternoon. Buenas tardes. Well, thank you for coming to share this present and important moment in which our university will award Dr. Marc Ballouz the honorary title of Distinguished Visitor reserved for relevant personalities in sciences. Congratulations, Dr. Ballouz, and thank you very much for your visit. Gracias por compartir este momento tan grato e importante en que nuestra universidad le otorgará al Dr. Marc Ballouz el título honorífico de Visitante Distinguido, reservado a personalidades relevantes en diferentes áreas del conocimiento, motivo por el cual lo felicito y le agradezco su presencia. The National University of Córdoba has more than 4 centuries of existence, and our faculty is almost 150 years old. The validity of a higher education institution depends strongly on its links with other similar institutions, mainly from other countries. The links with institutions such as the International Society of Soil Mechanics and Geotechnics and the Geo Institute of the American Society of Civil Engineers are leading global associations, and Dr. Ballouz, an outstanding professor whose presence honors us. La Universidad Nacional de Córdoba tiene más de 4 siglos de existencia y nuestra facultad casi 150 años. La vigencia de una institución de educación superior depende fuertemente de sus vinculaciones con otras instituciones similares, principalmente de otros países. Los nexos con instituciones como la Sociedad Internacional de Mecánica de los Suelos y Geotecnia y el Instituto de la Sociedad Americana de Ingenieros Civiles son asociaciones globales líderes y el doctor Ballouz, un profesor destacado, cuya presencia nos honra. Our faculty is one of the largest in our university and the second in the country in number of engineering careers. It is also one of the most diverse faculties in terms of knowledge, with 12 engineering careers, biology and geology, covering a great wide of science areas. On this sense, it is our custom to appoint a professor dedicated to a specific area to present the academic profile of the visitor. And there is no better in this case than our former dean, Professor Ingeniero Roberto Terzariol, to refer to the personality of Dr. Ballouz, which is why I invited him to come up. Nuestra facultad es una de las más grandes de nuestra universidad y la segunda en el país en cantidad de carreras de ingeniería. Asimismo, es una de las facultades más diversas en campos de conocimientos, los que van desde 12 ramas de la ingeniería, biología y geología. Por eso es nuestra costumbre designar a un profesor dedicado al área en cuestión para exponer la semblanza académica del visitante. Y nadie mejor en este caso que nuestro ex decano, profesor ingeniero Roberto Terzariol, para referirse a la personalidad del doctor Ballouz, por lo cual lo invito a dirigirse al atril. Thank you very much. Muchas gracias.
Good afternoon. I don't speak like Tarzan, I speak like Cheetah. So I speak better in Spanish. Así que voy a hablar en español, que creo que voy a hablar mucho mejor y que me van a entender todos. Marc es un destacado profesional de la ingeniería, un profesor formado originalmente como ingeniero civil en la Universidad del Líbano y luego hizo sus posgrados, tanto la maestría como el doctorado, en la Universidad de Texas, en el campus de A&M, o sea, en College Station, donde terminó, digamos, su formación y donde inició primeramente sus trabajos como profesor. Luego se trasladó al Líbano, en el Líbano ejerció como profesor y ejerció la profesión y como investigador escribió más de 200 papers, colaboraciones en artículos, participación en 2 libros y participó fundamentalmente en la Sociedad Libanesa de Mecánica de Suelo, Ingeniería de Fundaciones y en la Sociedad Internacional, de la cual hoy es presidente. Conocí a Marc hace 11 años, no, un poco más, de 14 años que lo conocí a Marc. Él era miembro del board, yo en aquel momento era vicepresidente de la Sociedad Internacional e hicimos una muy buena amistad en aquel momento. Él estaba en la comisión, estaba en la Comisión de Relaciones Públicas en aquel momento y posteriormente nos volvimos a encontrar en diversos congresos y reuniones con los cuales ratificamos profundamente la amistad que nos unía. Por eso fue una tremenda alegría para mí cuando él dijo que venía aquí, para Córdoba, y con algún grupo de profesores de la casa y profesores eméritos se nos ocurrió distinguirlo de esta manera y tuvimos el beneplácito de todas las autoridades, tanto de la facultad como de la universidad, para que ello así fuera. Así que le pedimos que cuando le diéramos esta distinción nos brindara una conferencia y él accedió amablemente y por lo tanto, una vez que terminemos con todas las presentaciones, les voy a pedir que la brinde para todos nosotros. Desde ya, muchas gracias a todos ustedes porque vinieron y thank you very much, Marc, for coming here and your deliver your lecture, okay? Thank you very much.
Muchísimas gracias por las palabras al ingeniero Roberto Terzariol. Vamos a invitar a la vicerrectora Mariela Marquicio a realizar la entrega del diploma que acredita como visitante distinguido de esta universidad al doctor Marc Ballouz. También le hace entrega de una medalla recordatoria de este momento. A continuación, solicitamos a las autoridades que desciendan del estrado para escuchar al homenajeado y su conferencia denominada Geotechnical Engineering, Marriage Between Theory and Practice.
This is working. I will speak in English, but very, very slowly. So you can see my face. Yes. So marriage between theory and practice, but first, since I am the president of ISSMGE, I will tell you quickly what is ISSMGE, especially that one of my best friends in life is from Argentina, Professor Marcelo Sanchez, coming here, and he is on the board, so we have to tell you together maybe what is ISSMGE, and especially that Professor Terzariol was the VP of ISSMGE. So very quickly, but before I start, this is where we are now. I was really impressed, and it's an honor, and it's a joy for me to be here in Argentina. There is something special in Argentina. I don't know what it is, but you know, when I go to conferences, the audience is bigger. I say it's an honor, pleasure being here, but there is something more special here. And it's something that, you know, touching. And I want to do something I've never done before, which is to kiss your country. So now these two countries, I love it. Thank you for having me here. So yesterday, or this morning, we came from Iguazu, and it's really heaven on earth. I cannot describe it, the joy I was there. You feel like you're in heaven. So I come from a very small country, Lebanon, and I have to tell you, because many of you don't know, but Lebanon is the only country in the Arab world with a Catholic president, and it connects us more and more. It's a democracy. We have snow skiing. You will see my picture, snow skiing. I was a champ. But if I keep talking like this, we will stay together till tomorrow. So I will start by telling you what is ISSMGE. It's the International Society for Soil Mechanics and Geotechnical Engineering. It was established, like we were talking before, in 1936 by the father of modern geotechnics, Carl Terzaghi. And it was in 1936 where about 140 professors and geotechnical engineers gathered in Harvard University. Here is a picture of them. And they was the first, if you want, international conference of geotechnical engineering. And here is Carl Terzaghi. And if you go back and look at the names, you see names like Casagrande, Lambe, and many other famous geotechnical engineers. They started representing 15 countries, but now we are 90 country members. Fortunately, Argentina is in red, so you are a member, very active member. And I am president number 18 after Terzaghi being president number 1. The structure, how we operate, so you see if you want the legislation, the 90 countries are the council, and then in the middle you have the structure, the core of the executive power, which is the board, with president, 6 vice presidents. So the current vice president for South America is from Brazil. I'm sure many of you know him, Andre Assi. And we have 6 or 7 now, the new one, board-level committees. So 7 board-level committees. And really, the most important one is the one led by Argentina, Marcelo Sanchez. He represents the horse, the working horse. No, it's okay, it's nearby. But maybe I should, no, it's okay. This is okay. So the technical horse of the entire society. So we were elected in May 2022. And we have about 40 technical committees that Marcelo is overseeing, and many people from Argentina are active on those technical committees. So these are like subspecialties of geotechnical engineering. Also, ISSMG has companies that help and members. We call them corporate associates. So you can be a platinum member, gold member, and silver member. And if you are representing a company, I urge you to join us. Especially for students, young engineers, take a look at our virtual university. We have about 100 plus for free, all open access, webinars, videos, lectures. Also take a look at our journal, 100, maybe more. and even thousands of papers in our online library, all open access. So ISSMGE has this mandatory rule that if you want to publish with us, it has to be for free. And all this to help the young engineers. What did we do new? Since 2 years ago, if you open our website, we introduced the interactive talk. Interactive international technical talk. So we bring people young and experts from all around the world, from academia and from the profession and industry. And they discuss one subject for about 1 hour plus, every month. We did already 20 of these, and it's been gaining popularity. We introduced the iZone. If you have an idea for us, you can directly plug it in. You don't have to contact me. We introduce all the activities on the map, so you can plan your trips. Also, they're listed. The most important one is the international conference coming up in 2 years in Vienna, and they're going to celebrate 100 years, of Carl Terzaghi for his first book, and 90 years of ISSMGE, and I will no longer be president in that conference. So every 4 years, they change president. And of course, we have other conferences coming up in La Serena next week for the Pan American Conference. We have one coming in Lebanon. And you can recognize we introduced the new pins for the board. This is something you will like. I started this idea, a dream, and it became reality. GeoWeb, Geoengineers Without Borders, is now active. And it's a dream at the image of Médecins Sans Frontières. Wherever there is a geo-disaster around the world, we have volunteers now and a structure to send volunteers to help in assessing and mapping and giving ideas. And this is Fernando Marino at the floods in Brazil a few months ago. Page down. This is another one with the landslide in New Guinea with Dr. Kupek. So GeoWeb is active, and I urge you to join us. And it's led by Pierre Delage from France, Professor Pierre Delage. This is something new. We launched the new bulletin. So the new bulletin is now, you can receive it on your phone, flip it. It's like an e-magazine, zoom in, zoom out, active videos. And so far we have 3 issues for this year. I don't know if you took a look at it, Roberto, but it's really nice. And it's like 60 pages for articles and news from all around the world. Geotechnical, of course. The Heritage Time Capsule is another project. It has its own website now with material in all languages. It's really something where we gather all our history and heritage. We created this as a new thing. I also encourage you to take a look. New videos, maybe you can view one of them to encourage member societies, our corporate associates. International awards. We have many international awards, but 2 of them are going all the time. The others are every 4 years. The main one is the Bright Spark Lecture Award, which is for young engineers. The president and the board decide that this young engineer is at the level to give a keynote lecture. And it's to encourage the young engineers to work hard, and we really have great lectures by young engineers. We call them BSL Awards. Whenever you have a conference, I encourage the organizers to look for 1 or 2 BSL awardees. They have to be 35 years and younger. Another major award we introduced is the award for the GeoLegends. Last year, let's see, 2023, we got 2 winners. Professor Yamlokowski, I'm sure many of you know him. He worked on the Pisa Tower. Unfortunately, he died 1 day before he knew he got the medal. And I had to give the medal to his daughter and his grandson. The other winner was Harry Poulos. I'm going in 2 weeks to Sydney to give him his medal. He had to wait 1 year because the medal is given by the president himself. And a very special medal was given for Neil Taylor for serving, because he served 24 years as Secretary General. We surprised him in Astana. Here he's taking the medal when we changed to the new Secretary General. After 24 years now, you will get emails from Andrew McNamara. 2024, and this is a solid gold medal, very expensive, like $3,000 plus. The two winners are Suzanne Lacasse and Norbert Morgenstern. When I gave the medal to Morgenstern, it was in Calgary, very small event, maybe like here, 10, 12 people. And one of the guys whispered in my ears, "Why did you come to this small event to give this important, the most important award to one of the most important engineers in the world in such a small event? It should be in a big event." I said, "No. What's important is that the president comes to the winner. That means he is more important, wherever he is, with his family, his wife was there, his friends. This is the particularity of this award. And the number of people doesn't matter, like in this room, it's a quality." So Suzanne Lacasse also, I went to Norway, gave it to her with her husband. It's time to go fast. I cannot tell you what I did so far as president, but in 2.5 years, I toured the world literally 4 times. Poor Rania, she had to travel. She loves to travel, especially if it's to Argentina. And attended about 200 events in 42 countries. I'm sure Roberto realized I'm older, much older than what you know. It's very tiring. For this presentation to end, I have one equation, which is a geotechnical fundamental equation. To understand soil better, you have to dig deep. To understand love better, you have to dig deep. So this is the equation. Soil equal love. Thank you very much. Now I'll jump to the marriage story, another love story between. So the second presentation is about the second presentation is about 40 minutes. It's really my experience with geotechnical engineering. I put it together. It's a little bit philosophical. I hope you will not be bored because it's geared to a bigger audience, mainly students, young engineers. But I will go faster. If you get sleepy, I will wake you up. And you can, because we're a small audience, you can interrupt me, no problem, and we can have an interactive talk. So it's with 4 chapters, and it's the Buchanan Lecture is an award given by Texas A&M University, where I started my grad school, and this is where Marcelo is teaching now. And the first Buchanan lecturer, I was a student when it was Ralph Peck as first lecturer in 1994. And I was a lecturer number 30 last year. So I put together this lecture, and the first chapter, marriage philosophy, in 4 paragraphs. I will start with the first paragraph, and it's about units. No matter how old you are, trust me, you have to always be careful with units. And if you are a renowned engineer and expert, you always do that, I am sure. More than half of the failures in my experience as a forensic engineer came from units and bad units compatibility. Imagine in America, sorry to say that, but in practice, they still use the English units, newtons, pounds and inches. It's crazy, but many problems around the world because of that. So these are my children, long time ago, maybe 15 years ago, to tell you that 10 milliliters of antibiotics saved their lives. But if you remove the small m from the unit, you can kill an elephant with 1 liter of antibiotic. This is how important the units are. No joke. And you will think, oh, this is only civil engineers. No, even the best engineers in the world, like they work in NASA. In 1999, they sent a photography orbiter around Mars. It's a $125 million satellite, and they lost it. It disappeared when there was a part shifting from one software to another, and the problem was between pounds of force and newtons. You may think, again, how could this happen? They fueled the jet with 22,000 pounds instead of kilogram, and this is a very nice documentary on YouTube. I recommend it, where the pilot, for the first time in the history of civil aviation, had to land the plane without any engines in Canada. It's a really, really nice documentary. Fascinating how he had to slow down the airplane by turning it sideways to hit the wind, to slow down so he can land it last minute. Beautiful documentary. But unfortunately, not all the time it's a success, as we will see in my presentation. Jumping to second paragraph, and I always tell the young engineers, don't ever use intuition to answer. Always go back to theory. And this is a small example. If you take the red line, which is a rope, we throw a rope from here all around the earth and tight it, or we take another rope, green rope. So the first one is the perimeter of the earth. But if you throw another rope, only 6 meters longer, so from here to the door, maybe a little bit more, and loosen it all around the earth, how high will it get? Intuition will tell you negligible, right? But if you do the simplest math equation of 2 pi r, you will see that it will rise 1 meter. Theory can be so simple, so never ever jump to conclusion if you haven't seen it before. So if you have seen it before, it's not intuition anymore, it's experience. Another example is the bending of the paper. Like if you take a paper, I will not bend, but if you take a piece of paper and you bend it 1 time, 2 times, 3 times, 50 times, how thick will it be? What is your intuitive guess? 10 centimeters, 1 meter, 10 meter? The simplest math will show you that it's 225 million kilometers. And this is like the distance, the average distance between the Earth and Mars, even beyond the moon. So that's to tell you, don't ever reply with intuitive thing before you do the math. And also before you do Solje. Solje is a principle I keep telling my students and everyone I show this presentation. I use the word Solje to show, always collect the data. Soil data, load data, geometry data, and history. Soil data, how many layers, where is the water level, testing from the lab. Loads, what are the loads you expect? Seismic, harmonic, whatever loads you have, vertical, lateral. And geometry, always talk to your architect. Always get the architectural drawings, even if you don't care about the architecture. bring them so you get a feeling. And I will show you later why. And history, of course. You have to go to the site, maybe ask, what did the neighbors do, blah, 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 to see if there was a failure before. And again, always visit the site, because this is, after you gather Soldier, this is where you start solving the problem. What's the mode of failure? What's the applicable theory? What software to use? And don't jump to Plaxis immediately, because everything is in here. So this is a famous triangle that Morgenstern explains as a stool. Safest structure is this pyramid between safety on the top, cost, and functionality. Just an example, anybody can build a bridge, but it will either cost so much, millions extra, or it will collapse. That's what makes us good engineers, is because we balance between the three. So what I'm saying is always run sophisticated thinking prior to sophisticated software and analysis. Again, use as many methods as possible, even the latest technology like 3D modeling, AI, BIM, digital twins, 3D visualization, holograms, like with geologists, they use it a lot. AI, remote sensing, drone mapping, all of this for sure. But we go back to the history, like this building, and this is what makes you feel strong. These are equations that changed our life. These are two equations that changed my life. Time to drink. So, if you see here, engineering life, what that means, I keep telling everyone, there is engineering in every move of your life. You can check the centrifugal force, you can check, let's see if it works. This one, we need Ave Maria. No? Atmospheric pressure. What do you think? It will work? Not all the time. So if there is atmospheric pressure, the glass can be 10 meter high, right? But no, it's only a few centimeters, so it should be easy to remove your hand. So there is engineering in every move in your life. The more you observe it, the better engineer you are. They tell us that static friction is stronger than dynamic, but it's not always the case. Sometimes dynamic, when applied with deformation and structural mechanics, becomes a better solution. I can stay doing magic all the time. It's not magic. But I encourage everyone to observe. The observational method of Terzaghi is what I really love. And if you do that, combining dynamic friction with centrifugal force, for example, here, I don't know why it's not working. Let's see. Yes. Marcelo, you witnessed this with me. So the more engineering you put in life, the more fun life is. I did few of those drifts with Marcelo next to me, but he will tell you later his experience. So now to the last part of the first chapter, geotechnical life as an example. The simplest one is walking on sand. And if you apply SolJ, we collect the soil data. Soil cohesion 0, friction 30 degrees for the geotechnical engineers. This is simple. Load female and male 55, 70 kilos. You are 50, Rania. 50? Oh. You're perfect. Footing surface, footing. So the foot for ladies is smaller, but the pressure, they're almost the same. The female may have little higher pressure on the footing, especially if they have high heels. But even here, if you look at the history, take a look at the history they leave behind them. You can detect that settlement, for example, is related to stress, not to force. And if you apply the most common equation, which is Terzaghis equation for bearing capacity, you will see that the pressure is 0.1 kilogram per centimeter square, but the pressure on the footing is 0.3 on the foot. So is this failure? In theory, it is failure. Why? Because failure is defined by us, the criterion. If the criterion is, I don't want to see any deformation on the sand, we fail. But if the criteria is different, it's practical, like geotechnical engineers, you know they sunk a little bit, so what? And then it stopped. Is damage acceptable? Yes, so it's not failure. This is the difference in theory and practice. In clay, this may not be the case. I just mentioned this for geotech. So if we keep going, now we look at more details. The suction, if you notice, they're not walking on dry sand. They're walking on wet sand and not on fully saturated sand. So if you add a little bit the suction component and you look at that and you play with the possibilities, you will see that, if they sink a little bit, 1 centimeter, and you have suction, they're safe because the ultimate bearing capacity is much higher, a little bit higher than the actual pressure. And this is what we call sensitivity analysis, where you play with different variables. But also you can do reverse analysis. If I ask you, what is the expected settlement if they walk on dry sand? Same equation, different thinking, all this crunching of the mind, and you can detect that if they go on dry sand, they will sink 5 centimeters, which is logic. I'll keep going. Now more fun, deep foundations. So, so if you bury yourself on the sandy beach up to the knees, and you ask your friend to come save you, and the question is, what is the force needed for your friend to lift you from your misery, knowing that the pile length is 0.6 meter, pile diameter, perimeter average, and the expected friction 2 tons per square meters, you can easily do the math. But first, I'll tell you the story of my father. He's an engineer since 1954, and this picture is 1962. He's here. He's still alive. He's my friend. And my father, one time, he got a phone call that a trench collapsed, and there was no cell phone. And he told them, I'm coming. But that was 1 hour away from his office. And that time, the backhoe excavation operator, he was digging. His brother was in the trench. So he turned the backhoe and tied his brother with the rope and tried to save his brother by pulling him out. But let's go back and do the math. If you do the math here, the force needed to pull you up with 2 legs to the knees is 720 kilos, so that's 10 times your weight. So this guy killed his brother by trying to save him. Always go back to theory. This is the core of my presentation. This picture is, I think, was a failure in Boston in a trench. Look how they cleared way below the knees before they pulled with the special harness. Now case histories. So we finished the first chapter with the philosophy. Now some fun projects. The projects, I have many projects, but I only took 3 of them in different parts of the world. The first one in Lebanon, second in Texas, third one is in Nigeria, where Roberto visited me because at the time I had a business in Nigeria also. First, the Lebanese one. This is the capital city of Beirut. You can see the snowy mountain on the top. Many people don't know that we have snow. The project I'm talking about is the old Hilton Hotel. And the goal here was for our company to stabilize the basements while another company is destroying the old building with explosives and implosion. So my job was to stop any damage around and below the basements. So we had to cut all the basements and put ground anchors that will take the dynamic forces, and that was a challenge. Everybody here was happy except me. I was so worried. But look at the tower, how it went down as one piece. Keep this in mind. So here, everybody was running, including myself, to see what happened. And I will go back to Solje. So we collect the soil, the geometry, the loads, lateral loads, of course, where we put the anchors. But the most worrying load was, for me, how to detect the impact of 20 stories on the existing mat. How is it going to turn and hit me on the sides? There is nothing in the code, nothing in the book, how to determine the force that's going to hit me lateral. And I had to crunch my brain and go back to original Fourier series, the equation I showed you, and using the history. So historical data from a similar demolition in nearby, but smaller buildings. So I had to exaggerate a little bit and go using the Fourier series from the time domain to the frequency domain. And when you do that, you can detect the peak acceleration, use those peak accelerations to determine the expected pseudodynamic forces. Keep in mind those deformation. I'm going a bit faster, but lack of time. So, anchor design, structural integrity design. Here I'm showing the 3 drill rigs that worked underground to finish the ground anchors. High pressure grouting using Italian Clivio pumps if you're a practitioner. And I like this slide because it shows some innovative ideas to put rubber tires to stop the absorption of the vibration. And the conical wedges of the anchors, we put steel tubes and weld them at the top so that the conical wedges don't jump with the vibration. And at the end, we check the tension in the anchor. If it's not as high as we want it, we can cut the weld, remove the tube, and retension, so for redundancy. Here was a big question mark until they cleared everything, and here I was very happy to see that all the walls are still stable. And you can see all the ground anchors that sustain the dynamic impact force. Quick analysis. Remember that curves? This is the theoretical curve, and this is the measured curve from the inclinometer. So at the bottom, they look fine, but at the end, this is where the column of the elevators, or the core, hit sideways and pushed passively, and the detection of the deformation was different from the predicted. So the question, is it a bad design? The answer is no, because you designed for worst case condition. In this case, we were lucky. And this is the new Hyatt Regency being built instead of the old Hilton. I told you I'll show you a picture of me skiing. This is me in Mount Lebanon. I'm still alive, so no worries. Some knee injuries. I will not do this again. This was 11 years ago when I met you. and this to change the subject to jump to the next case. I don't know how we're doing on time. Can I keep going with cases? Okay. If you get bored, let me know. I see people that are not sleeping, so it's good. Seabreeze Wind Farm is a farm for developing 400 megawatts using 174 Siemens turbines, each 2.3 megawatts. And at the time, it is all time ago, but let's look at SOILGE. I always like to go back to SOILGE. Soil data, CPT, SPT, and laboratory data. Always collect the soil, the geometry, give you an idea. This is a football field that is turning 100 meter and 120 meter high. These are big turbines at the time. It was in 2010, 2009. The loads expected, each turbine was 162 tons, but dynamically it's moving at 13 ton. You expect lateral force, especially at emergency braking, developing about 1,600 ton-meter of moment. I'm sure some of you saw such numbers with wind turbine foundations. And the question was, can we do a shallow foundation? Looking at the history of the area, with all the winds and gusts and hurricanes and surge waves coming from the Mexican Gulf of Mexico, the recommendation was to use deep foundation to avoid scour and erosion. Quick scenario for one, or what the case we chose, 2 lines of piles. But then I like to mention that the only reason we allow adding lateral load to vertical load is because the vertical loads touch the lower level and lower layers of the soil. The lateral loads affect the top layers. That's why we allow adding them together. Otherwise, it's a no-no, because soil is not elastic, you know that. At the time, we had 2 theories for lateral loads, rigid and flexible, with some criterion. So there was a missing link, which theory to use. And under dynamic loads, and this was my PhD dissertation, if you look at the equilibrium equation, differential equation, force degree, force level, I had to solve this. It took me 1 year to detect what's the deformation of the pile laterally at any location and any time as the wind is turning. And if you do that, and you type it in font 16, the solution was 33 meter long. Roberto, you can recognize the Ferrari, yeah? Good memory. The formula, yes. And again, marrying theory to practice, I made my workers here on lateral support carry the equation so that they feel it. I don't know why it's not working. Yeah, so this is the software that shows the movement of the pile within the maximum deformation envelope. Soil structure interaction, this is an example. Where I show that the same pile, the straw, in different soil, between sand and mayonnaise, I had to buy some mayonnaise from the supermarket, behave differently. And it's related to the structural criteria and the soil criteria. To make it simpler, you can do it with your own hand. So if you take a pen or a pencil and you push it against your fingers, the fingers, so I'm pushing the pile, the fingers are the finite elements of the soil. and the pen is the foundation or the pile. So in soft hands of a lady, it can be rigid, and if you're strong, not like me, it will not bend. It will bend and become flexible. Anyways, the new theory we developed can show all these differences, and the solution between the two is not an average. I will skip that part. These are the expected deformations of the foundation, and this is the Seabreeze wind farm. So, quick picture from the Jeta caves to change. I will drink. So the last case, I don't know if we have time for it. The last case is a quick one. Is a G-Law building, is a headquarter of a lawyer, famous lawyer in Nigeria. And he constructed this building, and one day I get a phone call from him, said, we have some cracks in the building, can you come visit me? So I went to visit him. He's sitting on his desk, 4th floor level, and he said, you know, I will let the engineers tell you about it. I said, don't let them say anything. He said, what? I could literally put my hand, full hand, in cracks, not in the walls, but in the columns, in the beams. I said, we have to evacuate immediately. It was the shortest business meeting in my life. I said, what? I said, we'll do the meeting outside. It's crazy. He was happy with the building, but didn't know how bad it is because his engineers were scared of telling him the truth. It was sinking 1 millimeter per day. 1 millimeter per day, constant speed, like this. One day this footing, the other day this column. It was sinking like this. And I was panicking. I mean, what are you guys doing? So the first thing I told them, remove all the loads, all the chairs, all the water tanks, air conditioners, whatever you can remove. And one engineer said, why? It's barely nothing compared to the structural weight. And I'll show you why. So again, Soldier, we collect the data, the layers, the water level. This is where the pile was. And they were micropile, Paliradici. And they were installed by a famous company. I don't know if I should mention, but so they were installing those micropiles, and then when the building started going down, said, oh, we can fix it. And they kept installing more micropiles. Here they're installing more micropiles and connecting them with steel beams far from the columns. So you see the column here, this is a micropile. And welding them, and the building kept going down. And this is when I arrived. I said, guys, you are doing a semi-good job, because by the time the micropile is activated, the building is sinking. What we should do instead is activate the micropile. Let the pile fail, not the building. So to gain the maximum capacity of the pile, you sink it, push it down with hydraulic jacks, and then you connect it to the structure. One micropile after the other, we were successful in saving the buildings, saving the building. So this is what we ordered, to activate the micropile and push upward the building ASAP, as soon as possible. And from sinking to thinking is what I want to show you. So if you look at the curve, I show two lines, one pile and 196 piles. But it's the same curve multiplied. The idea was, when I came, it was here. So it was sinking. Why I say remove as many loads as you can? Because if you drop just 10%, you stabilize on the curve. But they were here, and they kept adding piles. We kept adding piles until This is where the load and the movement stopped. So after it stopped, the lawyer was happy and said, okay, we stop now. I said, no, we need some safety. So I asked for some safety. But the next slide is the nice one. I started thinking, and I discovered there is a factor of 10 somewhere. And I discovered the problem. The problem was between the geotechnical contractor and the structural designer. He gave a number for loads. The geotech did not look at the architecture. He thought it's a one-story building. He put micropiles because the difference between tons and kilonewtons, unbelievable. And we almost lost the entire building. So the recommendation here is everybody should talk to everybody else. Final chapter, almost. Business as engineers. So I tell the young engineers, try to be in red, make things happen, and don't be in green. And you cannot be in green, otherwise you're not engineers. But this was by Butler, 1931. I liked it. Another thing I tell them, look at the temperature. In Argentina, you can be in all zones, which is good. But Argentinian engineers may have a problem going in Canada, in permafrost, for example. They have to be trained there. So if you want to be an international engineer, you have to look at this temperature map. And this is a more important map, which is my friend, the corruption map. In Argentina, you can work easily in Lebanon and vice versa, but it's going to be difficult, especially for a Canadian engineer to work in Argentina. You know why. To be honest, we're all the same. It's just the method. So it's either under the table in red or with a cameraman and you give the envelope to the mayor in America above the table in yellow. But this is a different discussion. Finally, my conclusion, which are some lessons learned or recommendation. Always collect the data, don't rely on intuition, do sophisticated thinking prior to sophisticated analyses. Don't limit yourself to the code because the code is limited to some cases. And never compromise safety, of course, always do the theory. Visit the site, do monitoring, value engineering, call the client, follow the project. It's the best way to learn. And always be ready to expand internationally and connect with me on LinkedIn. And this is the best part, which connects to my first presentation. Steve Jobs, before he died, during his graduation in Berkeley, I think, he said, the only way to do great work is to love what you do. And I love geotechnical engineering. Thank you very much.
Thank you very much. Marc Ballouz.
Sorry it took some time, but...
Muchísimas gracias por acompañarnos. Vamos a dar por finalizada esta ceremonia escuchando las estrofas del himno universitario Gaudiamus Igitur.